Okay, everyone, last but not least, we have example number 3, which is an application problem. You are on top of Mount Rainier on a clear day. You're about 2.73 miles above sea level at point B. Find the measure of arc CD, which represents the part of the Earth that you can see. Okay, so picture yourself here. You're up here at point B. You're kind of looking down over the Earth, and when you look down, you can kind of see like the horizon, which only lets you see like so far in each direction. So it's kind of like your field of vision or what you can actually see. Now, what we have to find is we have to find the measure of the arc CD. And my first thought is, well, if I can figure out this central angle, that central angle is going to have the same measure as that arc. So the question becomes, okay, well, how are we going to figure out that central angle? Okay, there's a couple ways to do this, so if you figure out a way that's different than mine, fantastic, but I'm just going to do it in what I kind of see as the easiest way. So what I'm looking at is I'm looking at this triangle right there. And on this triangle, I know a couple things. I know that this is 90 degrees because I'm dealing with a tangent line over here, and if that's marked 90, then that's 90. Which means I know the hypotenuse is 4,002.73 miles. Okay, we know the radius of the circle is 4,000 miles, which means over here is also 4,000 miles. And then if you take your 4,000 miles and you add on how high you are off the earth on the mountain, then that's what gets us that 4,002.73 miles. What I'm trying to figure out here is I'm trying to figure out this central angle, which is all of angle A. But if I'm just looking at this triangle over here, I could just figure out, I'll put a little theta in there. I could just figure out theta, and then once I find that, I could just double it to figure out all of angle A. If we go back to chapter 9 a little bit, if I've got theta as a reference angle, I know that the 4002.73 is my hypotenuse, and I know that the 4000 is my adjacent side. So if you're thinking about your SO, CA, TOA, adjacent and hypotenuse is a cosine. So I'm going to set up the equation, the cosine of my angle. I don't know the angle, so I'm just going to put theta, equals the adjacent side over the hypotenuse. Now, in this case, we're trying to solve for a missing angle. Anytime you're trying to solve for a missing angle, that's when you use an inverse trig function. So I'm trying to get theta by itself. I'm going to do an inverse cosine, and I'm going to do an inverse cosine. Inverse cosine cancels cosine. Theta equals inverse cosine of 4,000 divided by 4,002.73. Okay, grab your calculators, pull up your trig functions, grab your inverse cosine, type in 4,000 divided by 4,002.73, hit enter, and I'm getting that theta is about 2.12 degrees. Which means if this side over here where I have theta is 2.12 degrees, then the other side must be 2.12 degrees. So I'm going to double that. So 2.12 times 2 is 4.24, which roughly, if we're going to round that, we could leave it like that. But it's roughly 4 degrees. Now, if my central angle, the whole thing, is 4 degrees, and then I've got my intercepted arc, because it's a central angle, they're equal. So the measure of arc CD is approximately 4 degrees.